All right, so welcome to another edition of Developreneur. Today we are going to be talking about AssertJ packages, and it is a fluent assertions in Java. So instead of us using the traditional JUnit Assert class, we're going to be talking about this new library, AssertJ. So today we're going to be looking at unit testing with AssertJ. We're going to kind of briefly talk about the differences between or what assertions are and why they're important within unit testing. And then we're going to go into a full hands-on presentation using AssertJ methods and chaining within our unit testing. So first, let's talk about unit testing. So unit testing is software testing where we're testing the individual units of our source code. So we're testing individual methods. We're testing units of work. We're not testing the overall application. We're not doing regression testing. We're not doing integration testing within our application and other applications. This is solely focused on a specific unit of work, potentially a method in our code. Why is unit testing important? Well, it helps us to identify problems early in the development cycle. This lets us quickly catch bugs or issues with our code changes at development time. So as we're writing the code, we can test the code and say, oops, our change broke something, or everything passed, and we can then move on. Finding bugs and fixing bugs at this level is very cost effective because we're able to fix it now. Whereas if we waited till we did regression testing or manual testing of the application once it's been packaged and shipped, it's going to be harder for us to identify what that bug is or where that problem came from. So if we do unit testing right, we should be able to catch most of the functionality bugs within our application quickly during development. It also makes debugging the process easier because if we catch the bug in our unit test, we know specifically in our code where it broke. We know where to go fix the problem. Again, if we wait till the end when we're trying to package and ship the product, we don't necessarily know where the bug exists. So it's going to take more time and effort to go back in and dig into the code and find the problem. The other nice thing about unit testing is we can also reuse our code to migrate our specific test from, say, one application to another. So if we have similar code in one application, we could potentially copy that unit test, put it into the other code base, make a couple of tweaks, and boom, we're done. So unit testing, very effective. This is the first line of testing that developers can do while they're writing their source code. Now, this leads into assertions. What are assertions? Well, the Oxford Dictionary defines assertions as a confident and forceful statement of fact or belief, which really translates into what we're looking at when we talk about testing. So, from the JUnit or unit testing perspective, an assertion is essentially a collection of utility methods that support asserting conditions in tests. So it's like given some test scenario, when we give it some data, then we want to test something. We want to make sure that things work. Again, assertions is a confident and forceful statement of fact or belief. AssertJ is a third-party library that you can include in your project that is rich and easy to use. It is extensible. It's open source, so you can go extend the libraries. It is also community driven, so there are no licenses or costs to using this library. AssertJ provides a rich set of assertions, truly helpful error messaging, improves test code readability, and is designed to be super easy to use within your favorite IDE. And the whole reason I'm even talking about AssertJ today is because once I found this and I started using this, this really makes writing those unit testings and writing those asserts, writing those use cases, it makes it so much more readable and easy to follow in your use cases than trying to create a whole bunch of independent asserts with the traditional assert libraries that come with JUnit or some of the other unit libraries. So that's pretty much it for the slides. So we're going to jump out. We're going to look at the different APIs between JUnit Assertion and AssertJ, And then we're going to walk through a simple use test on how to use some of the functionalities that come with AssertJ. All right, so let's first start with assertions. In JUnit, the assertion library contains a whole bunch of helper methods that we can use to define assertions within our use cases. We can do things like assert all, we can assert arrays are equal to things, but basically there is an assert method for every type of test that you want to do, but you have to essentially assert for everything you want to do. So either you create if statements around conditions, or you have to basically define multiple assertion statements in order for you to test your library. So you have like assert equals, assert not equals, assert null, which is really useful in and of itself, like assert true, fail, but we don't necessarily want to have 5, 10, 15 asserts to essentially test a use case. It gets to be unreadable, unmanageable. However, with AssertJ uses fluents, so you can use method chaining, starting with an assert that instead of assert equals assert. You basically start with the declaration assert that, and then you can use fluent and basically chain any of the methods within the AssertJ, which is very useful. So the two locations to look at if you want to compare these, if you go to JUnit.org, JUnit 5 docs, and the version you want, then API index.html will bring up the JUnit API of your choice. AssertJ, you can get to by just Googling AssertJ and pick whichever index you want. But they are on GitHub. It is a weird URL. It is Joel-Castigliago, anyway, it's easier if you just Google AssertJ, go to their GitHub, and then you can find the APIs there. Let's go back to our code. So we're going to start with a simple test here. So let's look at our project here. So our project is a basic Maven project. I just named it AssertJ examples for clarity for this class. And I added 2 classes to my Java main package. So I have a calculator class from last time, which has all of our methods for adding, subtracting, dividing, multiplying. Basically the basic arithmetic functionalities for a calculator. We have factorial, and then we had our main class where we actually did the operations, where we took command line arguments and actually added up or tested our methods. So to start with, I want to introduce, instead of just jumping right into AssertJ, I want to show you how to write a unit test to test protected private methods within a class. So we'll start with this one, and then we'll move into testing our second class here, which is a basic POJO, a person, with a name, address, city, state, zip. So down in source test Java, I've created a calculator test class, and we will ignore this for right now. So in our calculator test, it is a JUnit 5 test. So I'm using JUnit Jupyter API test, which allows me to use the test annotations. And then I create a method to test the add two numbers method from my calculator. So we want to test this right here. We want to test this method. But this method is protected. It's not public. So I can't just say calculator, add two numbers, and go on. So to access a method inside of a class that is protected or private, you can use the method reflection class here, Java lang reflect method. And then we can go in and we can take the class name we want, .class. We can use the get declared method for the method reflection. We then can specify the method that we want. So essentially, we're defining the method within our test. So we're going to say, okay, get declared method. We want to get the method name, add. So basically, you kind of copy this here. So you get the method name, add two numbers, and then you also want to set the parameter types that you're going to have to pass in. So we give it the method name, and then we give it the 2 parameter types that we want to pass in, which are float. The next thing we want to do is we want to take our method reflection and we want to set it accessible. So we want to set it true. That way we can access that private protected method. And then you can just simply use a standard assert. This is not AssertJ. This is just a standard assert method where we can assert equals that the result of adding 2 numbers, 1 and 1, is going to be 2. We have to add the f postfix so that we can define this decimal as a float. We call our method add 2 numbers, returns result method, invoke. So we're going to invoke it. We're just going to say, hey, okay, call it. We define our new calculator. So we instantiate our calculator class. And then we pass in 2 parameter values of 1 and 1, which should equal 2. So if we run this, we should pass. Now, if this failed, it would throw the message, the sum should be 2. All right, so let's run this. And over here, if I extend this, we pass. But if I change this to 2 and rerun this, we fail. And if we expand this, you'll see that the message here that we added was written out. The sum should be 2, expected 2, but we received 3. So this is an example of using a standard assert method within our test case. Now, if we want to use AssertJ, we need to import some AssertJ classes here. So we need to include org.assertj.core.api.assertions. Now you could do .star, but in the standard world today, we only want to include the classes that we want. So for today's example, we're going to be looking at the assert that method, which is what we're going to start all of our assertions with. We're going to look at assert that throws by to actually test exceptions. So we can actually kind of force an exception for a method that may throw an exception, catch throwable, and tuple, which will allow us to go in and actually check different values within a object, which is very useful. All right, so let me go down here, add my test data back in. So for our AssertJ test, we are going to use our person class. So we're going to use our person Pojo to test some data that is being passed around. I kind of followed the example that they used on their website. I just kind of simplified it a little bit further without having to include all the additional classes they used for testing. Before we get to that point, though, you will need to also include the dependency AssertJ. So your Maven dependency will be group ID org.assertj. The artifact you need is AssertJ-core. And currently the version that's out there right now is 3.4.1. And I want to set the scope to test so that when I build the project, it will not include the test packages within my compiler. So test 1, let's look at a basic assertion test. So this is going to kind of be a very simple test, kind of like what we did here with the assert equals. So here I've created 3 persons, or I've defined 3 persons for testing. I've created a random person, John Smith, and Jane Doe, all with some different person data that we're going to test. So for our first test method, our basic assertions, we're going to follow the chaining method, the fluent method of AssertJ. So we begin our test with assert that, and then we give it our what we're going to test. So assert that here random person dot get name. So assert what it is we're checking. Then what do we want to test? So we have assert that. So let's look at this. So assert that can receive a string. But if we go look over here, so if we look at assert that, you see that assert that it's been overloaded to handle multiple different types. So we can take files, floats, just about everything possible within the Java language. We can take almost any type of class. So we can pass in anything. So say we want to assert a string is equal to another string. So we start with the string, then you can do dot, and now you have all your assertion or AssertJ methods that you can use. So you can check for, we'll talk about as in a second, but we'll stick to strings. So as string contains only, contains all, patterns. So you have a whole slew of methods now that you can test within this assert that method. Whereas if we just did the straight up assert equals or assert true, this is a one and done. You make this method call and that's it. So if you want to do another test or chain off of this test, you have to create multiple assertions. However, here with the assert that, it allows you to chain this test. So not only can I assert that random person.getName is equal to random person, I can also continue chaining off of the last method. So I can say, okay, is this equal to random person? Okay, cool. Is it also equal to ignore case? So you could actually essentially create your one test or combine all the things you're testing into one statement. Whereas again, with the assert, you would have to create multiple asserts that you would have to test. So if one failed, you would then have to go up, okay, this and figure out what failed. Whereas here, if you chain it all into one command, if this guy fails, you know that this is the line you need to go look at. All right, so let's start with the first part here. So how we read this, assert that random person.getName is equal to random person. Very readable. Now, if we wanted to do this up here, it would be something like this. So straight up assertion would be assert equals random person get name. Random person. So assert equals random person get name random person. Still fairly readable, but this reads better. Assert that random person get name is equal to random person. Assert equals random person name random person doesn't quite roll off the tongue as easily. The other thing is, okay, so if I did this, but then I wanted to do some additional things off of this, I would have to do another assert and continue. Whereas here, if I wanted to do another dot is equal, ignore case, I could actually add some other chaining here if I wanted to. Where here I would have to do yet another assert. All right, so there's the first two, or sorry, first one. And then the second one, not only can we check by string, but we can actually check by object type. So I can say assert that random person is not equal to John Smith. If we go up here, so random person should be this person object, and John Smith will be this object. So it actually allows you to compare objects as well. So if I save this and run, our test pass. Now, if I actually put in random person, this should fail because random person is equal to random person. And sure enough, it failed. So let's look at this. So our assert error, it's expecting person, name, random person, address, 123, is not to be equal to random person. So we fail. Another thing I like about AssertJ is the failure messages you get at runtime are so much easier to understand, and they're clean, they're easy to read, unlike assert methods. You would have to kind of expand upon the assert methods like so. Okay, so now we have this one, put it back so it passes. So that's just basic assertion. So that's very simple comparison between the two. So now let's look at this chaining method. So the second one here is chaining. So chaining allows us to chain different things. We can change strings specifically, we can chain collections, but for this one, let's just start with string. So here we're going to assert that John Smith dot get name dot starts with John. We can also check that it ends with th, and we can see if it is equal to ignore case John Smith. Again, if we wanted to do this as assert, you would have to do something like this. So here we have to essentially write 3 assert methods to do the same thing that we can do in AssertJ in one line. So here we can assert that John Smith dot get name starts with JOH dot ends with TH dot equals ignored case John Smith. A lot easier to read and very easy to understand. Where this gets convoluted, or if you have a lot of these, it's going to be hard to tell what exactly the test is doing. Okay, so those go back clean. Run this again. So if we look at our chaining, it passed. Now, let's make it fail. So let's say we did John by mistake. The first part should fail, that should pass, that should still pass, but the first part failed. And it failed. And if we look, we were expecting John Smith to start with John, and it failed because our name was actually JOHN. So it did not start with John, so it failed. Very clean, very easy to read. Okay, put that back to H, so this passes. All right, so that's chaining.
Well, hello, this is Rob with Developreneur, also known as Building Better Developers. Wanted to announce that we have school.developreneur.com. Feel free to check it out if you like any of this information, any of the content that we've sent, and you would like to see more. You can come out, you can enroll for free. We have free courses. We've got places for you to get better at just learning a technology, our how-tos. You can work on your business skills. We can help you with becoming a better developer, as in coding and things like that. A lot of the stuff you've seen on YouTube, we also have out at school.developreneur. We just have it in a little more of a educational format and a way for you to track your progress as you move forward becoming a better developer.